All right, so one of the good morning. One of the basics of trig is angles in standard position, right? Should you find yourself in 30-1, you are going to need to know angles in standard position. All right, it is a vitally important concept, right? So just in case you make it to 30-1, make sure you understand this stuff. So two rays with a common endpoint called the blank are shown. Let's give you the first letter. Vertex. The angle between the two rays is called a... You're not going to know this. I don't know why we don't just put them in there, but maybe writing the word helps. So it's a rotation angle, right? So what you imagine is you're starting at ray 1. Sorry, what?
Or she's a little bit sorry, this is a different sheet.
The arm. The two rays are called the initial arm and the terminal. Wow. All right. Hang on. Let me pause while I... All right, so you have a slightly different worksheet, and it says a rotation angle. Yo! We're back. Sorry, long commercial break, but the show has resumed. If you don't want to watch the show, go to the cafeteria, enjoy. A rotation angle is made up of two rays with a common endpoint called the vertex, which I guess you should know, because on your sheet it actually has the word vertex there. The two rays are called we'll call them the initial arm and the terminal arm. Ray 1, ray 2. So ray 1 is called the initial arm, and ray 2 is called the terminal arm. So if you're looking at the other worksheets, then just listen and fill in. Okay, now it should get pretty similar. An angle is in standard position if its initial arm is on the positive x-axis with the vertex at where? The origin. Or 0, 0. I don't know. What are we going to put in? Let's put in both. Positive angles are, okay, if it differs from now, just let me know. Positive angles are the result of a counterclockwise rotation. Okay, look up there. See the way the second hand is moving? That's clockwise. Okay, I know. Well, pretty soon, like your kids won't even be able to read that. What's that thing on the wall with numbers? I don't know what it does. It tells time. No, it doesn't, because telling time is like 2 numbers and then 2 numbers. So counterclockwise, right? Which is this way. Counterclockwise. And a negative angle results from a clockwise rotation. Okay, so if we rotate this way, clockwise, and it's from the positive x-axis, right? So the initial arm is always on the positive x-axis. As you rotate through, each quadrant is 90 degrees. So 0 degrees to 90, then 180, 270, back to 0, which could also be 360 degrees. This is quadrant 1, so the quadrants are named quadrant 1, 2, 3, 4, basically just in the order that you encounter them as you rotate. So you start off here, you're rotating through quadrant 1, then 2, then 3, then 4. Depending on the size excuse me, of the angle, the terminal arm could be in quadrants 1, 2, 3, or 4. Sometimes the terminal arm of an angle is on the x-axis or the y-axis. These are called quadrantal angles, okay, which would be 90 degrees, 180 degrees, 270 degrees, 0 degrees, 360 degrees, right, which is fully around the circle. So if it's the angle is between a quadrant, right, or between quadrants 1 and 2, 90 degrees, it's not in quadrant 1, it's not in quadrant 2, so it's called a quadrantal angle. If theta is an angle in standard position, then its reference angle is the acute angle. What's acute? It's small. It's cute. You know it's cute. But what's acute? Less than 90 degrees. Okay, so acute angle. So less than 90 degrees. Formed by the terminal arm with the x-axis. The reference angle is always positive. The reference angle is vitally important. More so next year than this year. I mean, it's important this year, but having the concept down for next year is vitally important. For each angle below, draw the angle and state its reference angle, theta sub r. So theta is the x of trig, right? I mean, x is the unknown in algebra, but in trig, it's always theta. Okay, so we want an angle of 40 degrees. So where's 40 degrees? Which quadrant is it in? Okay, so quadrant 1, you just draw an angle. That you draw, basically you're just drawing the terminal arm. Okay, put an arrow on it, it goes on forever. Label it 40 degrees. And what's its reference angle? So reference angle is the positive acute angle measured between the x-axis and the terminal arm. It's this angle here, which is 40 degrees. So a quadrant 1 angle, its reference angle is just the angle itself, right? 90 degrees. Where's 90 degrees? Okay, so straight up. So we draw along there. Now, we have to indicate the angle, right? We have to indicate that it's positive. We do that by rotating in A. So we should show the rotation, right? Actually, so instead of writing 40 degrees there, hang on, let's write this, and then we'll say theta is equal to 40 degrees. So show the rotation. And you do that with an arrow on there, right? Show that I'm starting here and I'm going to there. And we say theta is equal to 90 degrees. And what's the reference angle? 90 degrees. I mean, kind of in a sense, it doesn't have a reference angle. But we'll write it as 90 degrees. 165 degrees, where's that? Which quadrant? It's in quadrant 2. Where in quadrant 2? Is it like close to here or closer to here? Closer to the bottom, yes. So again, we show the rotation, can write in theta is equal to 165 degrees. What's the reference angle? So the reference angle is going to be in here. How much is it? So reference angle is measured from the x-axis to the terminal arm. It's always positive. Okay, so it doesn't matter if we think of the reference angle as being here or here. But what's this angle out here? Yeah, so reference angle is 15 degrees, right? So when I'm doing reference angle, I just think, how much further do I have to go to get to 180 degrees, right? So if you're in quadrant 2, the question I want to ask is, well, how much further to get to 180? That's your reference angle. 251 degrees. Where's 251? Quadrant 3. How far into quadrant 3? 71 degrees, which is also what? 71 degrees is the 71 degrees is the reference angle, right? So you think, all right, look, 251. All right, so 90, 180. I got to go another 71 degrees. So there's theta is 251 degrees, and then fill in the reference angle. Yeah, I'm in the fall 2013. It's just the top that's different. So the reference angle, and the way I do reference angles, I say, okay, I got to 180, right? So reference angle is going to be measured from the x-axis, which is either 0 degrees, or 180, or 360, because 0 can be thought of as 360. So if I'm in quadrant 1, it just is what it is. It's the angle. If I'm in quadrant 2, I kind of think, well, how much further to get to 180? If I'm in quadrant 3, I say, how far past 180 did I go? Right? Well, in this case, 71 degrees past 180, right? Because how do you get 251? 180 plus 71. 270 degrees. Where's that? Yeah, it's the quadrantal angle right here, right? So we're going to draw on top of that. Theta is equal to 270 degrees. What's the reference angle? Yeah, so theta r is 90 degrees, right? 323, where's 323? Quadrant 4. Where is it in relation to this line? I want to do it from here, though. So the question would be, how much further would I have to go to get to 360? No, well, 7 will take me to 330, so 37. So I'm 37 degrees short. So that means my reference angle is 37 degrees, right? That's why I always think when I'm in quadrant 3, 2, 3, or 4, I think of it as where am I in relation to 180 degrees or 360 degrees, right? So this, well, I got to go 37 degrees more. Now this is how I show the angle. So this is theta is equal to 323 degrees. I'm showing it as a positive angle because I'm rotating counterclockwise. And my reference angle is, well, how far off of here am I? Or what I ask, how much further do I have to go to get to 360, right? So I mean, just take it up to the nearest 10. So 7 gets you to 330, and then 30 gets you to 360. So 37 degrees. You can, of course, use your calculator, right? So here you would go like 251 minus 180, right? To say, oh, I got to go another 71 degrees. Up here, I would do something like 180 minus 165, right? So, well, I'm 15 degrees short of, right? I'm going to be short of 180 by 15 degrees. I'm going to be past 180 by 71 degrees, and I need to go another 37 degrees. Okay, those are your reference angles. 428. How are we going to show 428 degrees? Well, let's just count our way there. So starting here, we'll show the rotation. So I've got 90, 180, 270, 360. Okay, now how much further do I have to go from 360 to get to 428? 68 degrees. What does that make the 68 degrees? It makes it the reference angle. Okay, so I'm going to draw an angle here. So I'm going to show theta is equal to 428 degrees, and theta r is equal to 68 degrees. Now how do we know that's 428 degrees? Well, because we have to go once around the circle is 360, and then another 68 degrees to get to 428. What could we say about 68 degrees and 428 degrees? They're the same, right? They have the same terminal arm. If I just drew that arm in there, and you took a protractor, measure it, and say, that's 68 degrees. Well, no, it's not. I'd say 428 degrees. They're the same. Okay.
Do we need like a protractor?
You don't need a protractor for this. An amateur one will do just fine. 517. All right, so we got to get counting by 90s here, right? So we got 90, 180, 270, 360, 450. How much further from 450 to get to 517? Okay, it's another 67 degrees. Okay, so that's theta is 517 degrees. Now, what's 180 if we kept going, right? So it's like 90, 180, 270, 360, 450. What would we come next? After 450, we get over here. 540. How much more do we have to go to get to 540? 23. What's 23? Referencing. $660. 90, 180, 270, 360, 450, 540. What's after 540? What's down here? Just add 100, subtract 10. 540, 640, 630. Okay, 630. How much further do I have to go to get to 660? Another 30. 630.
How do you go from?
630. Maybe you woke up at 6:30. It was too early for you. Okay, put the arrow on which indicates the rotation, right? That we are rotating this way. Here's the arrow, it says you're ending up there. This is theta, which is 660 degrees. Okay, so that's 630. I came 30 degrees. How much further would I go to get up here? 60 degrees. So theta r is 60 degrees, right? Reference angles measured in here. It doesn't matter which way you measure the reference angle, be it positive, so you just say, well, I'm 60 degrees short, so I got to go back 60, or I'm going to come up 60. Either way, it's a positive and it's a cube. So it's theta rep is 60 degrees. Okay, and it's the angle between the x-axis and the terminal arm. Negative 95, which way do we go? How far? Okay, so this is 90 and then 5. So this is theta. Now, put an arrow on here to indicate the rotation, right? We'll ask that on a test, right? So, say draw me an angle of negative 95, right? And you need to draw this and put that and then list it. Theta is equal to negative 95 degrees. So how far did I come this way? How far is this? 5. So how much further is left to go to get to here?
85.
So what's my reference angle? Okay, and it's going to be positive 85, right? So reference angles are always positive. Negative 200. Okay, negative 90, negative 180. Let's go 20 more. Let's put an arrow on here. So we say theta is negative 200 degrees. Always remember the degree symbol. How much further did I come from here to here? Because this is my reference angle. So what's this distance? Or what's this angle? 20. Okay, so theta r is 20, right? So it's like negative 90, negative 180. To get to negative, I got to go 20 more. Oh, that's going to be my reference angle, right? 20 degrees. Negative 510. Well, we got to go around once. There's negative 360. And, okay, to do your angles, just add 100, subtract 10, right? So like 90, or 100 minus 10 is 90. 90 plus 100 is 190, minus 10 is 180. I mean, you should know that 90, 180, 270, 360. When you go above that, you go 460, 08, back up 10, 450. So I would need 510. I'm at 360. This will be 450. To get to 510, I'm going to have to go another 60 degrees. Now, how much further would I have to go to get to here if I went 60? I'd have to go another 30, right? Because every quadrant has 90 degrees. And here, I'm going to put an arrow on, indicate my direction of rotation, and list my angle. Theta is equal to negative 510. All right, so we good? You can draw any angle in standard position. Positive angles, negative angles, you can figure out rotations. Okay, what's next? Express each direction as an angle in standard position where theta, is it on your worksheet?
Yeah.
Good. Okay. Hopefully it's the same. Let me know if it's different, right? Like, don't let me blather on for express each direction. So there are navigation angles. Okay, so they're angles, so everybody's heard of northeast, south, and west, right? There's navigation angles, you're heading north, whatever. In navigation, north is 0 degrees, right? We just decided that we're just going to have two totally different systems of angles, and we're going to have things called bearings and things called headings. So north is 0 degrees. East is 90 degrees, south is 180 degrees, west is 270 degrees, and north could also be 360 degrees. So we do a couple of things different, right? 0 is at the top, and we rotate clockwise to give positive angles. Okay, so it's a positive rotation going around. We go around the other way, right? Instead of starting at 0 and going counterclockwise, that's just the way it works. That's not confusing at all. And actually it isn't. I mean, it's two separate things. You just have to separate it and say, I'm doing math, it's math angles, therefore 0 degrees, is the positive x-axis, and we rotate counterclockwise. And you know, if you get into anything where you'd have to use navigation, so if you're a pilot or you're flying, you know, boating, stuff like that, orienteering, navigating with a compass or with a GPS that's showing you directions and stuff, that's how this is set up. But there's another one, and this is called a heading. So here's how headings work. East 25 degrees south. This is where you start. You start facing east. This is the direction you turn towards, and this is how much you turn. So this is east 25 degrees towards the south. Okay, now, to bring in for you kinesthetic learners, all right, so everybody stand up for a sec. Just stand up. Okay, we are going to face east. Which way is east? East is this way. Okay, that's north. That's south. That's east, that's west. So we're facing east. I want you to turn 25 degrees towards the south. Well, you gotta figure out which way south is. That way. That fooled you, right? Okay? All right, let's do south. I want you to face south. I want you to turn 62 degrees towards the west, which is the back wall. Okay, so you are now on a heading of south 62 degrees west. I want you to face north, which is out the window. I want you to turn 20 degrees to the south. Now, the problem is, if I said that, it's like, well, but south is directly behind me, so do I turn to the left or do I turn to the right? That's why you'll never see, in a heading, you'll never see opposite angles. You never see east something west, right? Because you can't really do that. You'll never see north 25 degrees south, right? So I always have to give you an angle that's 90 degrees opposite. So I say face north, turn 45 degrees towards the west. You do that. Okay? So that's how headings work. I pause because they're also bearings. So a heading of east 25 degrees south, here's what we draw. So you say there's north, there's south, there's east, there's west. So you start off east and you go 25 degrees towards the south, so that's 25 degrees. That's your angle. Now, as an angle in standard position, now forget northeast, southwest, we want an angle between 0 and 360, so take away the north, south, east, west. This is your rotation angle. So what is it as an angle in standard position? Yeah, so it's 360 minus 25, right? If you want to figure out the rotation angle, so, well, that's 25. So I've gone 360 and then I've gone down 25, right, or lower by 25 degrees. 360 minus 5 is 355, minus 20 is 335. So theta is 335 degrees. Okay. How do we figure that out? Well, we went 360 degrees minus 25. So we have the reference angle, right? The angle standard position will be 360 minus the reference angle. Okay, I want you to do south 62 degrees west. So you say, all right, well, there's south. And I'm going to go 62 degrees to the west. What is that as an angle in standard position? Well, we got to start here. Rotate, right? And we're doing, this is called the principal angle. The principal angle is an angle between 0 and 360, right? Because as we saw, 68 degrees, 428 degrees are the same. Okay, so if we want to talk about, yeah, well, what's the lowest angle that it could be? The lowest possible positive angle? That's this guy. It's called the principal angle. All right, so what's this angle? 208. 208? So you could say, if I go all the way to 270, then I'm just going to go 270 minus 62, which gives me 208. Or you could say that's 62. This has to be whatever angle gets me to 90. So the reference angle here is going to be, well, to get to 90, I got to add 8 and then 20. So that's 28 degree reference angle. And I've got 180 plus 28 gives me 208. Okay? So I don't care how you get the angle, you just got to be able to get that angle, right? Which is 208 degrees. Okay? So Those are headings. These guys are called headings. So a heading just starts with you facing one of the cardinal directions, right? So northeast, southwest are the cardinal directions, right? Then we've got the other, you got northeast, northwest, southeast, southwest. So you're lucky you live in Calgary, so you're very familiar with the whole idea of northeast and northwest and southeast and southwest. So you know the city is divided. This is the northeast quadrant, northwest, southeast, southwest. This is Center Street. This is Center Avenue, which there really isn't one of. It's kind of the Bow River, it's kind of this one, right? But, you know. Yeah. Okay, directions can also be given in bearings. A bearing is an angle rotated clockwise from due north. Express each bearing. Okay, so remember, so for a bearing, 0 degrees, 90 degrees, 180 degrees, 270 degrees, north, east, south, west. Okay, and again, 360 is sometimes used. So instead of saying 0 degrees, so I might say 360 degrees. Okay, 23 degrees as a bearing, right? So we're starting at north, which is 0. We are rotating 23 degrees this way. What's my angle and standard position? Okay, so this is a bearing of 23 degrees, right? Bearing is an angle measured going clockwise from north, which is at the top. I've gone 23, 67, right? Yeah, because you got to make 90 degrees, right? Every quadrant is 90. A bearing of 300. So you can see, well, 300 is going to be, well, okay, this is 0, 90, 180, 270. I'm going to go another 30. So this is a bearing of 300 degrees. We want this angle and standard position starts here, goes to here. What is it? 150. Yeah. Okay. So just think, I mean, this is 30 degrees sitting in here, right? That's a rep. So if the reference angle is 30, you say, well, how far did I go so that I'd have to go another 30? It's like 180 minus 30 is 150. Right? So when we start thinking standard position. So occasionally you're going to get some questions, right, which are legit questions. You know, so-and-so's out and they're walking and they walk east 25 degrees south, and then they stop and they turn, you know, on a bearing of this, they turn on a bearing of 87 degrees and they walk another bit, and you've got to draw a diagram and label all the angles in the right place. Okay? Generally, we try not to mix bearings and headings, but it might happen. Okay, coterminal angles. Draw the standard position angle 100 degrees. Okay, so where's 100? Where do I go? How much further? Past 90, how far past 90? 10 degrees. Okay, so there's theta is 100 degrees. 460 degrees. 90, 180, 270, 360, 450, okay. 460. Theta equals 460 degrees. Negative 260, negative 90, negative 180, that'll be negative 270, so I'm going to stop there. Negative 260 degrees. 820. How many in 2 rotations? So 360, 720, and then we'll have to go another 100. There's theta is 820 degrees. Now, what can you say about all of these angles? They're all the same. They all have the same terminal arm, right? I mean, they're not all the same. One is 100 degrees, one is 460, but they have the same terminal arm. So if I didn't show you this rotation, then you wouldn't know. Well, is that angle 100 degrees? Is it 460? Is it negative 2? Yeah, it's all of the above. So all the angles above are coterminal, meaning that their terminal arms are in the same position on the coordinate plane. But the amount of rotation is different. But there's another blank, another way we can fill it, and it's different, but it's plus or minus 360 degrees. Let's write it this way. So you think, well, there's 100 degrees, but then there's 460, right? Well, that's just what I've already done. I've gone to the 100, then I've gone around once more. Or I've gone to the 100, but then I backed up 360 degrees, right? I went here, and I rotated 360 that way. It became negative 200. Or I rotated to here, and then again, so I went 2 more times around the circle. What if we talk about the reference angles? What are the reference angles of all of these angles? They're all the same, right? They're all not 9, they're 80 degrees, right? Reference angles 80 for each of these. Reference angles are all the same. So remember, reference angle is just a positive acute angle. It's between 0 and 90, between the terminal arm and the x-axis. Right? One positive and one negative coterminal angle for each of the following. So 123 degrees. What's a positive coterminal angle? What would we do to get it? What would I add?
360.
Add 360, right? Just go around the circle one more time. Okay, what's that? So 483. And how do I get a negative coterminal angle? Subtract 360 degrees. Right? It's a little harder than adding. What's that, 237 or something? So it'll be negative 237 degrees, right? I mean, you have calculators, so by all means use your calculator, right? Negative 400, I need a positive coterminal angle. So, yeah, I mean, adding 360 won't do it, right? So we got to add 2 360s. We'll add 720 degrees. Okay, which will give me positive 320 degrees. How about a negative coterminal angle? Well, we could just add 360, right? And get negative 40 degrees. Or we could subtract 360. And get negative 760 degrees. State all angles beta coterminal with 220 degrees if beta is between negative 720 and positive 720. Okay. So what do we have to do to get all the coterminal angles between negative 720 and positive 720? Well, we just add or subtract 360, right? So let's go 220 degrees plus 360. What is that? 580 degrees. What happens if I add 360 to 580? It goes over 720, right? So we're not going to just add 300 to that. It's like 880. Okay, so we don't need to keep adding. All right, let's go the other way. What's 220 degrees minus 360 degrees? I'd wait, but I'm impatient. So it's negative 140. If I subtract 360 from negative 140, will I still be in the range? Yeah, okay. What's negative 140 degrees minus 360 degrees? Negative 500 degrees. If I subtract another 360, what will happen? Now I'll be lower than negative 720, so we don't need to keep going, right? So those are all the coterminal angles within that given range, right? From negative 720 to positive 720. Write an expression for all angles coterminal with 220 degrees. Well, if we want to write an expression, it's going to become something that you commonly do, especially in 30-1. So we said, well, we're going to start with 220 degrees, and we are going to add 360 n degrees, where n is any integer. Okay, so say n belongs to the integers. right? So n could be 0. Well, if n is 0, what do you get? Just 220. N could be 1. What do you get? 220 plus 360. N could be negative 1. 220 minus 360. N could be negative 2. That would give us the negative 500, right? If we did 220 plus 360 times negative 2, we get negative 500. So these are all of the coterminal angles. So that's how you write it. Get used to that kind of notation. You're going to see it a bunch. Okay. So it's just the angle plus, okay? We just use plus because the n can be positive or negative, right? So we don't need to say plus or minus. We just say plus some integral multiple, right? Some integer multiple of 360. State one positive and one negative angle and an expression for all angles coterminal for each of the following angles. Okay, so we want a positive angle. What would a positive angle be? So it just says state. We don't need to show any work. There's a positive angle, 430. What would a negative angle be? Negative 290. What are all the angles? Okay, you cannot forget the n belongs to the integers, right? But I wrote that 5 times on the previous 4, it doesn't matter. But I already wrote it in part A, it doesn't matter. You gotta write it in part B and part C. You don't get to leave it off, right? It's not your choice to say, yeah, but, you know. 518, a positive coterminal angle. At this point, I think I need a calculator. So, yeah, 878, sure, you can add. You could also subtract 360, right? No idea what that would be, but I could subtract 400 and then add 40. So it'd be 158. That's 158 degrees. It can't be negative 180, this much I know. Negative 180. 518, so 180, 548. Negative 202. Okay, so you're just going to subtract 720, right? Negative 202 degrees. Now I want all angles. Now, I would be tempted to, I always like going with the positive, the principal angle, right? I don't know why we haven't defined that yet. But the principal angle is the smallest positive angle between 0 and 360. I think it's nicer to go with that, but I'll let you get away with either. So you can write like 518 degrees plus 360 n degrees, where n belongs to the integers. Or you could write 158 degrees plus 360 n degrees, where n belongs to the integers. Okay. Either one for that question would be acceptable. I like the 158 better, right? That's the principal angle. Negative 610. Let's just add 720. What does that give us? Positive 110? Yeah. And let's just add 360. It would be like adding 40 and then adding 400 and then subtracting 4. Wow. What's negative 610 plus 360? Like negative 250. All right, so there's a positive coterminal angle, there's a negative coterminal angle. You want all angles, so you could write negative 610 degrees plus 360 n degrees, where n belongs to the integers, or the principal angle, which is 110 degrees plus 360 n degrees, where n belongs to the integers. Okay, what's next? The reference angle of an angle theta in standard position is shown. State the value of theta if it's between 0 and 360. So you got a reference angle. We want the principal angle, right? Principal angle is the smallest positive angle between 0 and 360. So reference angle 78, what is theta? 78. Quadrant 1 is nice, right? Reference angle is 35. What is theta? Come on, Sam. Look, it's 180 minus 35, right? When you're doing reference angles, you're working off of 0 or 360, which is the positive x-axis, or you're working off of 180. This angle is 35 degrees short of getting to 180. It's 180 minus 35. This angle is 70 degrees more than 180, which is 250 degrees. And this angle is 18 degrees shy of 360. So 342, right? So what do I do here? 360 minus 18, right? So that's calculations going on. You have 360 degrees minus 18 degrees. This calculation, 180 degrees plus 70 degrees. This calculation, 180 degrees minus 35. So quadrant 2 angle, you're always going to go 180 minus the reference angle. Quadrant 3 angle, you're always going to go 180 plus the reference angle. Quadrant 4 angle, 360 minus the reference angle. Complete the following table. This is the last part, right? Yeah. What is this? I gotta make this a bit smaller so we can fit the following table. What do I go with? 150? Nope. Is that the whole thing? Yeah, it's pretty much the whole thing, right? Scooch it a bit this way. That works. Okay. The angle is 50 degrees. Sorry, the reference angle is 50 degrees. What's the quadrant 1 angle? 50 degrees, right? Quadrant 1 is nice. So the quadrant 1 angle, there's your reference angle is 50 degrees. So theta is 50 degrees. What's your quadrant 2 angle? Okay, so the quadrant 2 angle is 180 degrees minus 50 degrees, so 130 degrees. What's your quadrant 3 angle? Okay, so it's 180 degrees plus 50 degrees, which is 230 degrees. And what's your quadrant 4 angle? Yeah, so theta is equal to 310 degrees. Theta equal. And this is 360 degrees minus 50 degrees. Okay, do the next one. You should be able to do the next one, right? Do the next line. Does it say like state? It says complete the chart. So your best bet really is just to sketch in your reference angle and then figure out your rotation angle. Sketch in your reference angle. And what is that? Sketch in your reference angle. What is that? And sketch in your reference angle. Okay, so are those the numbers you got? Are those the numbers I got? So now we come down to, so in general, what's theta r? If it's theta r, what's the quadrant 1 angle in terms of theta r? It's just theta r. If we're in quadrant 2, what's the quadrant 2 angle in terms of theta r? Yeah, so 180 degrees minus theta r. If we're in quadrant 3, then it's 180 degrees plus theta r. And if we're in quadrant 4, it's 360 minus theta r. Okay? Reference angles are vital for next year. Okay, so reference angles are vital for next year. Just be able to figure them out, and to just without doing a chart. But if you have to sketch it out, it's a good idea just sketch it out, right? Very quick sketch eliminates a lot of problems. Okay, and we're